Welcome to the Algorithms and Software Engineering course from Eduonics. Let's just take a moment to introduce the course. When you study algorithms, you find they are broken down into categories, and the categories relate to the function, but they also relate to the domains of computer science that use these algorithms. For example, signal processing. There are classes of algorithms that we think of as being signal processing algorithms. There are algorithms that support compiler theory, cryptography, data analysis, algorithms that work with specific data structures like graphs that are becoming very important with the emergence of graph databases. The course is broken down into 9 sections. When we look at stacks and queues, this is the sort of work that supports compiler theory. When we look at divisibility operations and primes, this is the sort of work that supports cryptography. Then we look at tree-based algorithms and graph algorithms. These are the algorithms that support searching graph databases, for instance. While it's good to know that the algorithms we look at have applications that are important in computer science and the programming domain in general, it's also important to understand that before we can progress in these difficult domains, we need to understand the simple concepts really well so we can build on them for the more advanced work. So we have these simple practical exercises that support the concepts. So for every section, there are 3 laboratories. So in each of these 9 sections, there are laboratories where you will have to write code yourself. And that will give you a chance to reinforce these concepts that you learn from the theory in a practical context. Another area where the study of algorithms is important is in job interviews and tests. To help, the practicals often demonstrate these types of questions, and one important skill in that context is to be able to grasp or understand what the question is actually asking. If you know the concepts, then when you get a complicated, difficult to grasp question, if you can first seek to understand what is the concept that the question is testing, and once you identify the concept, it will be easier to apply the information given in the question to using that concept to obtain a solution. A good example of this is in the study of primes. Public-private key cryptography is based on this simple concept where you have this extremely large number of 40 digits, and it has 2 prime factors. One of those prime factors is the private key, the other prime factor is the public key. This is a simple idea behind public-private key cryptography. It's a challenge to write the code because of the magnitude of the numbers involved. Success in that challenge depends on your understanding of key concepts from related domains such as mathematics. In the section on divisibility and primes, we will look at some of the algorithms that you use when you work developing these prime factors of these large numbers that underpin this branch of cryptography. This scope and sequence document will be important as you progress through the course. It breaks down the steps that you take as you work through the course. So for every topic, it lists the sections. It lists this document ID to help you identify the correct document in the documentation folder, and it lists the actual video that relates. So this scope and sequence relates the step to the topic, to the section, to the document for that section for that video. Let's move on now to the first section, iterations and transformations on sequences. So we will need to find document with the ID 1 and the first video, iteration section1.mp4.